The F-35 Lightning II is the world's most advanced tactical fighter, being the tip of the spear for the US and partner nations in providing multi-role capabilities and strengthening national security. The NAV F-35 team is partnered with the Lightning Support Team under Fleet Readiness Center East in NAVAIR, whose primary focus is on implementing upgrades on and maintaining multiple variants of the F-35 Lightning Fighter in Cherry Point, North Carolina. The F-35 possesses two Maintenance Interface Panels, or MIPs, that are accessed by ground crew to perform pre-flight and refueling operations. There have been many instances where the MIPs have inadvertently departed from the aircraft mid-flight, causing significant damage to the airframe. While the root cause is unknown, likely culprits point to improper rigging of the existing latch system and no physical indication of the fully locked panel for ground crew. The objectives of the NAV F-35 project were to conduct a full redesign of the MIP latch system to prevent it from departing the aircraft in flight, simplify its installation and operation for maintenance crew, ensure it can withstand 400 pounds per latch, maintain a physical indication of the open-close status, and ensure full adjustability for variances on the panel and aircraft. After many iterations of the latch design and receiving consistent guidance from our amazing supporters, the team was set on moving forward with the linear wedge design. This design features a linearly actuating wedge to secure the panel, an angled receiving block mounted on the aircraft to reduce wear, a rack and pinion gear design to reduce debris buildup in the driving mechanism, a fully adjustable split collar locking system to adjust the wedge's lock position, and an adjustable tool interface to maintain a flush surface with the skin of the aircraft for stealth purposes. To operate the latch, a hex tool is inserted into the latch, pushing the locking pin up and out of the adjustable split collar. The tool is then rotated to drive the linear wedge into the adjacent receiving block. The hex tool is then removed from the latch, allowing the locking pin to fall into the locked position. Early on, the team utilized additive manufacturing to create a double-sized latch for hands-on verification of the functionality of the design. Following this step, the manufacturing process for the metal latch prototype consisted of milling, turning, CNC machining, and lots of wire EDM. Due to strict standards set by NAVAIR and Lockheed Martin, the latch must undergo a series of tests to ensure that the latch can perform in environments subjected by the aircraft. However, to begin testing the functionality of the latch, the team created a mock panel assembly to simulate closing it onto the aircraft. Following the delivery of the prototype to NAVAIR, it will undergo various tests to ensure a safe, reliable, and effective design to replace the current mechanism. Overall, the intent of the project was to make the F-35 a more safe and maintainable aircraft that will help ensure readiness of the fleet for years to come.